Let's go with our today's topic. What is a Verilog Testbench? A very important topic because we have created some duty with the help of my previous videos, but you cannot test your design up till now. So after this, you can test your design is correct or not. So simple definition is our testbench is a non-synthesizable Verilog code. It is a Verilog code, simple Verilog code written to check our design, but it is not synthesizable because a real thing is our duty. We are checking with the help of testbench. Written to verify the functionality of design. Yes, you can verify the functionality. For example, you are using a multiplexer. It is having multiple signals input and one output, whichever you select with the select line. So you will check this kind of functionality with the help of our testbench because duty itself cannot generate its input. We have to give some input. For example, you are using a calculator. A calculator, you will give the input to that hardware, a plus b, and some instruction. Then it will show you an output. That instruction is given with the help of our testbench, and that design whichever we are testing, it's called design under test because we are testing the design. So it does not represent a hardware. As I said earlier, it is not a hardware, it is just environment which will check our duty. It stimulates the design with inputs. So we are giving some inputs, that is called stimulus because we are stimulating the hardware and it will give out the output. So it stimulates the design with input, checks the output and response. So that output or response of that duty is we are checking that response is correct or not. A simple thing. Testbench only is used for simulation environment, not in chip. So when your chip is fabricated, the internal part is all design and hardware. There is nothing related to our testbench which we are writing. And this testbench, Verilog Testbench, mostly designer write, a verification engineer write with the help of the systemverilog or UVM, which I will create the course after completing this Verilog course. But for designer, it is important to write a Verilog code because Verilog testbench. Because for Verilog, a simple Verilog can make a simple testbench which can give that you are going correctly for designing or not. Okay, so purpose of testbench. Verification ensure RTL logic is correct before sending to sequence. As we know that verification we are doing before because we want our RTL without a bug. Okay, so apply stimulus to duty. As I said earlier, we are giving some stimulus, observe and display the outputs because we are getting some inputs in our duty. We will check our outputs, compare with expected behavior. So we can have a scoreboard kind of thing in our Verilog, mostly in system Verilog. So we can compare that how much cases are failed or how much cases are passed as our expected output. We can create a mimic the behavior of your DOT and you can check if you are expected that inputs are same or not. But in simple Verilog testbench we are not doing this. We will see this more deeply in our system Verilog course. For now it is not important. Detect design bugs before fabrication. So we are testing and that bugs are found out before sending it to our fabrication because if we create hardware we cannot change the small things after fabrication, right? So this compare with expected behavior, we will just for example, if we are taking a multiplexer, so we know that if we are selecting a line A, then output should be A. So we will be comparing in that way, not writing some code for that. Okay, so let us assume a simple 2 input AND gate.
Hit subscribe, like, and comment now. Let's begin the journey of verification.
And as all the videos, input module and input A and B is there, output is Y. And here is our assign block, which is our logic A and B will be the output. And here I haven't declared wire because by default in variable data type is our wire. For variable data type is wire in Verilog. In system Verilog it is logic. So here is a wire, here is wire, and here is a wire. Okay, wire. So in this testbench we have our duty inside our testbench, right? So it is one layer above our duty, and in duty the signals are wire. Okay, Y can be range or wire. If you are writing a always block logic, then it will be the range, but for now it is wire. Okay, Now this is our duty, and we don't know our duty, we only know that input output, and we don't care about what is inside duty. We will check that part for now. Okay, and you use the calculator, you give some instruction a or b, a plus b, for example a and b for now. So you will see the output stored somewhere inside your calculator, right? That is our duty part. But for testbench, we are checking our inputs, we are storing our inputs and checking our output. So what happens in our testbench, inputs are rich because we are storing the input, because we want to store that what we are giving to our duty, and by storing we will give. So our inputs will be our rich and output will be wire. Because we don't care about wire, we will just observe this wire or y in our waveforms or in our terminal, but we want to store our inputs. We mostly focus on our inputs, we are mostly focused on stimulus in that part of way, that what are we giving, at what interval we should give. I will show in this testbench. Fine. Okay, yeah, see here we are using a and b as a rich and wire as a y, and this is our top layer. Testbench is our top layer. So this testbench doesn't have input output. Why? Because it is giving inputs, we are storing inputs and giving this to our duty, and this is the top layer. Duty has input and outputs, testbench doesn't have input and output. So here you can see only the declaration of testbench signal is there with the help of data type. Module and module will be same, and as I said earlier, it is a top module, so there is no port. This is top, and inside that we will instantiate our duty, and instantiation name of duty and that original duty name. Let me show you this AND gate, and after that a simple name whatever you want. Then dot a means dot a of this duty, and this a which we are giving the name a. So simple for others also. And if you want to write a positional mapping for that, for example this, then you have to match the position of this module. For example a, b and y, so you cannot change the order, then you have to give like a comma b comma y. But in positional mapping you can change, like you can write this one first anyway, because connection will be proper, because we are giving his instruction that a dot a will be first, that duty signal, and your testbench signal. Fine. So this is our positional mapping, and this is our positional mapping, and this is our named mapping. And now we will apply the signal. As initial block we are applying the signal. This is also not synthesizable block. And monitor, this is our system task. I will create a separate video after this video for our monitor or system task video. So monitor will just monitor all the inputs a, b and y, what is happening to that input at what interval of time. Okay, and we are giving a as a 0 first, b as a 0, and after 10 nanosecond we are giving a this, b this, then after 10 nanosecond after a this, b this, and this all signals we are giving to our a and b. So these inputs will go to our a and b, and then duty, and then duty will process these input, and that we will get in y, and y we will absorb this input with the help of our monitor. So this is our simple testbench. So we will create more testbench and more of this practical kind of thing, but for that we have to complete the theory part. So for next video I will complete our system task and everything. So thank you, and comment me for any other topic you need.
Please Lord give me a sign, a sign.